Hello everyone. Today we got an interesting problem-solving problem. I don't know what the fuck. Anyways, yes. Okay, so we're supposed to prove that 1 plus 1 over the square root of 2 plus 1 over the square root of 3 all the way up to 1 over the square root of n is larger than or equal to the square root of n for all positive or natural numbers n. So how do we prove this? We prove it by induction, of course. So firstly, we prove for a specific case, for the smallest case, n is equal to 1. Then okay, it's just 1 is less than or equal to 1. That obviously works. So therefore we, for our induction assumption, we assume I can just call this equation star. So we just assume star for n is equal to k, and now for the induction step we have to prove that star holds for when n is equal to k plus 1. So what do we have then? If we just write up the expression. Okay, well, firstly, on the left-hand side, we'll start with that. What will we have? We have 1 plus 1 over square root of 2 plus all the way up to 1 over the square root of n, and then plus 1 over the square root of n plus 1. And this is then supposed to be, this is supposedly larger than or equal to the square root of n plus 1. Or sorry, we should use k. I'm sorry, I wrote k there. Yes, k. But firstly, we can just note that from our induction assumption, this thing here is larger than or equal to the square root of k plus 1 over the square root of k plus 1. Induction assumption. And then this is then supposed to be larger than the square root of k plus 1. And now we just multiply by k plus 1 everywhere because that's a strictly positive number. So then we would get the square root of k times k plus 1 plus 1 being larger than k plus 1, because the square roots cancel out. So we can erase those things and then we square both sides. So then we just get that k times k plus 1 is larger than or equal to k squared, which absolutely holds because that is equivalent to saying that k is larger than or equal to 0, which we are assuming it is. So therefore, proof concluded. And obviously you have to write, and by the induction axiom, the proposition holds. Yeah, something like that. So yes, that was everything for me. Hope you enjoyed the video. And check out the link in the description, and I'll see you some other time. Bye bye.